Hello, champions. How are you all? I hope everybody is good and fine. So, this is me, and I welcome you today in this lecture of electricity. This is lecture number first of our topic electricity. So, let's begin this lecture without wasting our time. Okay, so what we are going to discuss, we will discuss about electricity. So, what is the definition of this term? It is the branch of physics that deals with study of charges. So what is it? It is the branch of physics that deals with the study of charges. So what are charges? So although we will understand later what are charges, but for now I want to give you a brief about charges. So basically there are two types of charges. There are two type of charges. Okay, and what are those two types? The first type is positive charge, and the second type is negative charge. So because we are in class 10th, so we are obviously familiar with the concept of electron and proton. So proton carries positive charge. On the other hand, electron carry negative charge. Okay, so proton has positive charge and electron has negative charge. So the flow of these charges generates electricity. So why we are getting electricity? Because of this flow of these charges. I hope guys you might understand what I want you to understand. So let's move on to the next slide. So here some theoretical points are written. I am reading these points and after that I will explain. So electric current is expressed by the amount of charge flowing through a particular area in a unit time. Okay. So basically we understand what is electricity, but how do we express it? How do we define it? So this is the definition of electric current. So it is the value of amount of charge flowing through a particular area in a unit time. So let's suppose this is a metallic wire. This is a metallic wire and it has electrons flowing like this. Okay. So what would happen if I want to calculate the electricity or the current here, then how can I calculate it? I will simply write Q upon T. Okay, it means that the time taken, it simply means that in 1 second, how many charges flow in this area. In 1 second, how many charges are flowing in this area defines electricity. So now you might be confused, sir, what is the meaning of this I? What is this Q and what is this T? So basically, although we will understand this later, but here I'm telling you, you just need to remember that this is electric current. This is electric current and this is charge and this is time. Okay, so how many charge is flown through a area, through a particular area in a unit time is known as the electric current. Now, in other words, it is the rate of flow of electric charges. You can also say that it is a rate of electric flowing of electric charges because let's suppose, let me give you an example so that you can easily understand it. Let's suppose this is a metallic wire and let's suppose 2 coulomb charges. Coulomb is the unit of charge. Okay, so 2 coulomb, you can simply write it by C. C thanks to C refers to coulomb. Okay, So 2 coulomb charges are flowing in this metallic wire in 4 seconds. So if I calculate the rate of flowing the charges, then how would I calculate it? I will simply divide this 2 by 4. So by doing this, I will get the rate. Okay, because in 4 seconds, 2 coulomb charge is flowing. So in 1 second, 1 by 2 coulomb charge will flow. So this is the rate, and this rate is only known by the electricity. Okay, so I hope guys you got my point. In circuits using metallic wires, electrons constitute the flow of charges. However, electrons were not known at that time when the phenomena of the electricity was first observed. So this line is saying us that when we first found out about electricity, that time we didn't know about the electrons. Okay, so but the electricity, or you can say the metallic wires, constitutes lots of electrons, because in this, if this is a metallic wire, then this consists lots of electrons. Okay, so this is the reason that metal is a conductor of electricity. Metal is a conductor of electricity. Why? Because it has lots of free electrons. But on the other hand, if I talk about non-metals, then they are generally non-conductor of electricity. And what is the reason? Because it doesn't have free electrons. It does not have free electrons. So that's why the non-metals are non-conductor of electricity. Free electron. So I hope guys you might have got my point. Now, so electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. So let's suppose this is your electron, okay, and it is flowing in this direction. Now you tell me what is the direction of electric current. So in this case, the direction of electric current is this. So this is the opposite direction of flowing of electron. Okay. And it can be also said that the direction of proton, let's suppose proton is moving in this direction. So the direction of current will also be the same of the direction of flowing of proton. So I hope you got my point. Conventionally, in an electric circuit, the direction of electric current is taken as the opposite to the direction of the flow of electron, which are negative charges. So the same thing I had explained here, that the direction of electric current is the opposite direction of flowing the electrons. So I hope guys you might got my point, and let's move on to the next slide and let's try to understand what is there for us. Okay, so here we are. A switch, a switch makes a conducting link between the cell and the bulb. A continuous and closed path of an electric current is called an electric circuit. Now, if the circuit is broken anywhere or the switch of the torch is turned off, the current stops flowing and the bulb doesn't glow. So basically, here it is written that, let's suppose this is a metallic wire. This is a metallic wire and it has lots of electron like this. Okay, and let's suppose I connect it with a battery. What is a battery? Battery gives it some voltage so that it can flow the electrons. Okay, and I will be telling you, I will be explaining you about battery later parts, but for now on you just need to remember that battery gives it some potential or some voltage so that it can flow current in it. So guys, here we had heard two terms. First is battery, second one is voltage. So you are not familiar with these two terms, but I will be telling you this later. Okay, for now you just need to understand that voltage helps it to provide current or to flow current in this metallic wire. So what happens? The current will only be flowing in this circuit until it is completed. Okay, if I break the circuit, let's suppose if I break the circuit, then it will not flow any type of current. Okay, it will not flow any type of current. Why? Because the circuit is not completed. If I want that this conduct electricity or this flows current inside it, then I have to complete the circuit. I hope guys you got my point. So for the flow of current or the flow of charges, or you can say flow of electron or protons, the circuit is to be completed. So here an example is given. Let's suppose this is a bulb, okay, and this is a battery. So in this case, the current is passing through this bulb. The current is passing through this bulb. So it is glowing. Okay. But if I disconnect the circuit, let's suppose, okay, let me again draw this diagram for you. This time we will make it with another pen. Okay, so let's suppose this is your bulb and this is your circuit, but in this case the circuit is not completed. So what do you think? Will the bulb glow? So the answer is no. Why? Because the circuit is not completed. So that's why no current will flow inside the bulb, and that's the reason the bulb will not glow. I hope guys you get my point. Now let's move on to the next slide. Okay, so here we are. If a net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section is I is equals to Q upon T. So basically, this is the formula which I had told you in the previous slides, that the flow of the flow of charges is known as current, or you can say in other words, then the rate of flow of charges is known as current. So what is the rate of flow of charges? If I divide this from t, then I will get the rate of flow of charges, and that is equal to electric current. Now guys, the SI unit of electric charge is coulomb. The SI unit of electric charge is coulomb, which is equivalent to the charge contained in nearly 6 into 10 to the power 18 electrons. Here 18 will come, 6 into 10 to the power 18 electrons. So guys, I hope you got my point. So what is the definition of 1 coulomb? So 1 coulomb is the charge carrying by 6 into 10 to the power 18 electrons. 6 into 10 to the power 18 electrons. Now, how did we get this quantity? So basically, we already know that one electron carries the charge of minus 1.6 into 10 to the power minus k 19 coulomb. Okay. So if I want to know that 1 coulomb charge is carried by how much electron? So I will simply cross multiply this here, and I will get 1 upon 1.6 into 10 to the power minus 19, and you will get this answer 6 into 10 to the power 18 electrons. So I hope guys you might get my point, and now it's time to move on to the next slide. Okay, guys, so here we are. 1 ampere. Now, SI unit of electric current is ampere. Okay, let's suppose, let's take an example for your simplicity. Let's suppose this is a circuit and this is a metallic wire. Okay, this is a battery and 2 coulomb charge is flowing in this circuit in 2 seconds. Now, if I ask you what is the current electricity, what is the electricity, or you can say what is the current in this case, then how would you figure out the current? It is very simple. You will simply apply this formula Q by T. Q is charge, T is time. Then 2 coulomb charge is flowing in how much time? In 2 seconds. So simply 1. So it means 1 ampere. Okay, so you will not only write 1, you have to add its unit as well. You have to write it with its unit. So its unit is 1 ampere. Its unit is ampere. Okay, guys, I hope you got my point. The unit of current is ampere. Now, what is the value of 1 ampere? Or you can say, what is the meaning of 1 ampere? How can you define 1 ampere? So, simply, 1 ampere is constituted by the flow of 1 coulomb of charge per second, that is 1 ampere. Okay, so how can you define it? For an example, 1 ampere, how will you get 1 ampere when 1 coulomb charge flows in a circuit in 1 second? Then the value of current is 1 ampere. So I hope guys you got it. Now let's move on to the next slide. So here we will understand the types of electricity. The types of electricity. Let me change the pen here. So the types of electricity. So there are two types of electricity. First one is static electricity and the second one is current electricity. So the electricity which we are discussing here is current electricity because the charges are flowing here. The charges are flowing here. Okay, just like the current of air, whenever air is flown, we say current of air. Current of water, current of water. Okay, so simply the current of charges. Okay, let me write it clearly. So current of water. So if the same thing happens with charges, then we call it current electricity. But what is static electricity? So you can understand it by its name, then it is static. It means the charges are not running, the charges are not flowing. It is static at its position. So that type of electricity is known as static electricity. So here I have also given an image so that you can easily understand it. This is an experiment which we usually do in our classes. So let's take a comb and rub this comb in your hair. Okay, and after you rub it, and when you bring it close to the papers, bring it close to the small pieces of papers, then you will realize then the paper starts to get attracted towards the comb. So how this is happening? Why the paper is being attracted to the comb? Because when you rub it in your hairs, what happens? The electrons present in your hair, because of the rubbing, the electron present in your hair come on the surface of this comb. Now this negative charge, you have to remember that negative charge always attract the positive charge. The negative charge always attract the positive charge. So this negative charge will attract the positive charge present in the small pieces of the paper. Okay, so that's why it gets attracted towards it. So here you can see that the charges are not flowing, they are stable at their positions, but even you can see that there is some force between negative and positive charges. So this is known as static electricity. So let's suppose this is your positive charge, this is your negative charge, and these charges are getting attracted towards each other. But what happens if both the charges are of the same nature? Let's suppose this is a positive charge and this is also a positive charge. Now, in this case, they will repel each other. They will repel each other. Why? Because they are of same nature. Okay. Now, let's suppose this is a negative charge and this is also a negative charge. Then these will also repel each other because they are of same nature. So, guys, I think your concept might have been cleared that what is the difference between static electricity and the current electricity. Now it's time to move on to the next slide. Okay, so here we are. Here we have to study how do metals conduct electricity. How do metal conduct electricity? So for conducting electricity, a metal should possess free charges. These things, these things we have been looking since the very first time when we started this lecture. Okay, that for conducting electricity there should be free electrons. If there is no free electron, then the electricity cannot be conducted. So this is the diagram of a metal. This is a, you can say, diagram of a atom of a metal. Okay, so you can see the atom is constituted by protons, neutrons, and electrons. Proton has positive charge. Proton has positive charge. On the other hand, electron have negative charge, and neutron is neutral. Neutron is neutral. It doesn't have neither positive charge nor negative charge, so it is neutral. So here in this case the metal has lots of negative free charge. It means it has lots of electrons, free electrons, so that's why it can conduct electricity easily. But in the case of non-metal, it doesn't have free electrons, or you can say it doesn't have free negative charge. That's why it will not conduct electricity. So I hope guys you get my point. Now let's move to the next slide. Okay, so this is a metal wire. This is a metal wire. Let's suppose this is a wire of metal. It has lots of free electrons. Okay, but they are moving randomly. They are aligned randomly. For an example, this is moving in this direction. This is moving this direction. So because they are in opposite direction, so they will cancel out their effects because it is flowing current in this direction and it is flowing current in just opposite direction. So the net current will be zero. Net current in this case is zero. Why? Because they are aligned in different directions. But guys, what if I connect it with a battery? Now in this case, what will happen? All the electrons will start flowing, all the electrons will start flowing like this, and they will all flow in the same direction like this. They will all flow in the same direction. So Here you can say that the electricity will be conducted because they are not cancelling each other's effect. They are all flowing in the same direction. So that's why in this case the electricity will be flowing. So now you don't need to take stress about these terms which have been written here, low potential, high potential. We will definitely discussing these terms later parts, but for now on, you just need to study about the charges or the flow of charges. Now guys, after having a basic idea about this, let's move on to the next slide. So direction of current. So direction of the current, I told you that is always taken in the of the proton, direction of the proton, or the opposite direction or the opposite direction of electron. Okay. So in this picture you can see that the electron is flowing in this direction. So now you tell me what is the direction of current? The direction of current is this because this is just opposite of the direction of flowing of electron. Okay, so this is how we calculate the direction of current. So you just have to remember this one point, then direction of current. Let me again write it for you. Direction of current equals to the opposite direction of flowing of electron. So I hope guys you might get this. Now let's move to the next slide. Here we will discuss, okay, let me adjust this here. Okay guys, so you can see that some quantities are written here. First one is electric charge, second one is electric current, third one is potential difference, resistance and resistivity, heat generated due to current and electric power. All these things we have to study in this chapter. Yet we had discussed electric charge, electric current, or you can write it electrical current also. Now we are yet to discuss potential difference, resistance, heat generated due to current and electric power. So we will definitely discuss it. But for now on, we need to have a quick idea about the positive and negative charge. So this is your positive charge. This is your negative charge. There are two types of charges. We already know it. So this is positive and this is negative charge. Okay. I hope you get my point. Now electron carry charge of minus 1.6 into 10 to the power minus 19 coulomb. So let's suppose this is an electron. Now if you are asked how much charge does it carry, then you will simply say it is carrying 1.6 minus 1.6 into 10 to the power minus 19 coulomb. And what about the charge on proton? So to calculate the charge on proton is very simple. You have to simply change the sign of the charge on the electron. So here, because electron has negative charge, so that's why I added a negative sign here. But because the proton has positive charge, so that's why I added a positive sign here. So plus 1.6 into 10 to the power minus 19 coulomb is the charge present on proton. I hope guys you got my point. And this is the smallest charge in our body. This is the smallest charge in our body because we are made up of cells. Cells also made up of atoms. And in atom, there are the smallest units of atom is electron and protons. So this is the charge of electron and proton. So that's why this is the smallest charge in our body. I hope guys you get it. Now let's talk about the symbolic unit. So the symbolic unit of charge is Q. As we have been writing it since a very long, so we already know it that the symbolic unit of charge is QE. Now, what is the SI unit of charge? So, SI unit of charge is coulomb. Like whenever you have to write that I say that there is a two charge in a body, then it doesn't have any meaning until unless I add a C here. C is for coulomb. C is for coulomb. So there is 2 coulomb charge. You can say that there is 2 coulomb or 3 coulomb charge on a body. Then we will understand that you are talking about charges. And this is the symbolic unit of charge. So I hope guys you understand this lecture and I'm ending this lecture here. I will see you later lectures. Bye bye.